and welcome to today's video, which will be on converting between fractions and decimals. As you can see here on the left in blue I've got some fractions, on the right in green I've got some decimals, but how do we convert from one to the other? Well, to start with, I'm going to talk about how we convert from decimals into fractions, because this is slightly easier. If we take a decimal such as 0.5, now I'm sure you're all aware that 0.5 is equal to a half. But what if you didn't know that? How could we work it out? Well, as we've talked about in previous lessons, one of the things you can do to a number to keep it the same is multiply and divide by the same number. For example, we could do 0.5 times 3 divided by 3. Wouldn't help us, but we could do it and we'd still be left with 0.5. What I'm going to do here is 0.5 times 10 divided by 10. Except I'm going to rewrite that divided by 10 as a fraction. So here we then have that 0.5 equals 5 over 10. 0.5 times 10 is just 5. And then we can cancel out the factor of 5 to get that it's equal to a half. If we do that for the other two decimals that I've got written down here, we've got 0.26. Now, if I do times 10 over 10, we get that's 2.6 over 10. Not very helpful, but I can do my trick again. Another times 10 over 10, which equals 26 over 100. And then you can cancel out the factor of 2 to get that is equal to 13 over 50. Finally, 0.34271. Now, if you keep multiplying through by 10, you will eventually get that this equals 34,271 over 100,000. You can check you're going to multiply by 10 once, twice, 3 times, 4 times, 5 times, and 10 to the 5th is 100,000. You could then check to see if there are any common factors, but there aren't. 34271 has no common factors with 100,000 other than 1. So how do we go the other way? How do we convert from a fraction to a decimal? Well, for something like a half, as we've seen, that we know that it's equal to 0.5, but how can we work that out? Well, as we saw from converting decimals to fractions, we always wanted to get the decimal in the form something over a multiple of 10, a power of 10. So if for converting to fractions into decimals, we basically do that in reverse. We want to get this so that the bottom is just a power of 10, so a 1 followed by some zeros. How do we do that for a half? Well, we can multiply by 5 over 5. 5 over 5 is still 1, therefore we're not changing the number because multiplication by 1 doesn't change anything, but it enables us to rewrite the number in a more usable form. We find that this is equal to 5 over 10, and then we can use place value. So that's 5 times 1/10. And as we know, in place value, if we've got coming down hundreds, tens, units, then our decimal point, then we get tenths, hundredths, thousandths, etc. So 5 times 1/10 is just a 5 in the tenths column. So we would then write that as 0.5. So again, I had written up there 3/4. 3/4 as a decimal, as I'm sure you're all aware, is 0.75. But how would we work that out? Well, we can try timesing by 5 over 5 again, but that would get us 15 over 20. What we can now do is times by 5 over 5 again, which gets us 75 over 100, which we know just to be equal to 0.75. So, you can have a turn yourself now. Convert into fractions, preferably in their simplest form. 0.4, 0.28 and 0.343. Feel free to pause the video if you need a bit more time, but the answers are, so 0.4, I really need to stop doing that, equals 4 over 10, which equals 2 over 5. 0.28 is 28 over 100, which is 7 over 25. There's a factor of 4 in both 28 and 100. And then 0.343 equals 343 over 1000, and that cannot be simplified. Okay, now in reverse, write 1/4 as a decimal, 3/5 as a decimal, and 19 over 25 as a decimal. Again, pause the video if you need a bit more time, but for 1/4 you find that's equal to 25 over 100, which is therefore equal to 0.25. For 3/5, you're going to want to times by 2 over 2 in this situation to get 6 over 10. And then for 6 over 10, that's just equal to 0.6. And finally, 19 over 25. Multiplication is 4 over 4 here. To get 25, it would become 100. And if you do that, you get, quickly mentally work out, 19 times 4 is 76 over 100. And that does simplify down to, no, sorry, we're turning it into a decimal. Lost my train of thought. That is 0.76. Apologies. Okay, you may have seen at the start, if I scroll back up, I have 2/7 written down here. Now 2/7 is a lot harder to turn into a decimal for the simple reason that it's not a terminating decimal. And what do we mean by a terminating decimal? Well, we mean something like 0.76. It stops there. But if we take something like a third, which I'm sure you'll know equals 0.3333 and so on ad infinitum. Sometimes see this written as 0.3 with a dot above it, or 0.3 with a line. Every fraction, unless the denominator is purely a power of 2 or 5 or some combination thereof, is a recurring decimal. So 1 over 3 is a recurring decimal, anything over 7 is a recurring decimal, anything over 6 is a recurring decimal, etc. Only difference is if it's a power of 2 or 5 or some combination, which basically means that there is some number that you can multiply to get it over a power of 10. Example, 1 over 40, if we were to multiply that by 25 over 25, you'd get that as 25 over 1000. So how do we work out the decimals of, or recurring decimals of fractions like this? Generally we don't, it's not something we're asked to do, but there is a way, and that way is this. 1 over 7 equals 1 divided by 7. That's just the definition of the fraction. And then we write this as a long division. Except obviously we can't just do 1 divided by 7 like this, so we add in some zeros. See, this whole number is still 1. It's 1.000000. It's still 1. There's nothing else there. But we can now treat this as a normal long division. 7 doesn't go into 1, but it does go into what is effectively 10 one time. Subtract 7, we get 3 with our mass of zeros. Obviously this is 0.3 just to keep track of where we're going, and there is a point at the top. All of these decimal points should be aligned. The 7 does not go into 3, but into 30 we get 4 times. Subtract 28, again keeping track of where our decimal point is, and then we can go on. So 20, it's 2 times. $60, it's 8 times. $40 is 5 times. $50 is 7 times. If we were to continue, we'd get, it goes once into 7, and we'd go again. We'd repeat the exact same process, and we would get another chain of 1, 4, 2, 8, 5, 7, and so on. So, in fact, through this rather tedious process of long division, we find that 1 over 7 is equal to 0.142857 recurring, so you can either put a dot above the 1 and the 7, or you can draw a line over the whole thing to show that that's the recurring section, as it were. Now this is not very fun, but doing it in reverse is slightly easier. So let's do this in reverse. Let's say 0.3 recurring. We know that's a third, but let's show it. So 0.3 recurring equals 0.33333 ad infinitum. That's a terrible 3. Which means that 10 times 0.3 recurring equals 3.33333. And 10 times 0.3 recurring minus 0.3 recurring is obviously 9 times 0.3 recurring. But we also know that 10 times 0.3 recurring minus 0.3 recurring is 3.33333, etc., minus 0.333, and so on. And as you can hopefully see, all of these 3's after the decimal point get subtracted, and we find that that just equals 3. 3 point nothing, 3.03 exactly. So we now know that 9 times 0.3 recurring equals 3, which means 0.3 recurring equals 3 over 9. We then simplify that to be 1 over 3. And we can do that for any decimals. The trick is we multiply by 10 to the n, where n is the length of the repeating period. So if we wanted to show or work out what 0.142857 was, well, that's the repeating period, has a length of 6, so we'd multiply by 10 to the 6, which is 1,000,000, and we'd get that 10 to the 6 times 0.142857 minus one lot of 0.142857 just equals 142,857, which we happen to know equals 999,999 times. I should really keep drawing the lines in. Equals 9,999. Yeah, 999,999 times 0.142857 recurring. We can then write that as 142,857 over 999,999. And if you were to simplify that, you would find that simplifies down to a seventh. So, finish this video. Your turn. Work out the fractions that are equivalent to 0.27 all recurring, 0.44 all recurring, and 0.345 all recurring. Again, do pause the video if you need a bit more time. Otherwise, the answer's coming now. So 0.27, find that 100 times 0.27 recurring minus 0.27 recurring equals obviously 99 times 0.27 recurring, which equals 27. So 0.27 recurring equals 27 over 99. And then if you simplify that, factor out the 9, you find that's 3 over 11. 0.44, same process, you find that 0.44 is equal to 44 over 99. You factor out the 11, you get that is 4/9. And finally, 0.345 through the same process you would get equals 345 over 999. Then common factor of 3 is going to equal 109 over 333. So that's it for today. Hopefully you found this useful, and I will continue because there's a bit more to do on recurring decimals next time. But until then, just keep up.